Hello friends and greetings for the day. Welcome back to another tutorial on ISTQB Advanced Level Test Management Certification. We are in chapter 2 talking about managing the product and continuing ahead with 2.3, that is defect management. And today we shall be picking up the next segment, that is 2.3.5 defect report information. And here we'll be mainly talking about what information to be included as a part of defect report depending on the objective of defect management. If you quickly recall, in our previous tutorial, we told you that it is important for us to understand what are the objective of defect management. When it comes to objective of defect management, there could be multiple ways. Why are you interested in gathering the information? And these ways can further be defined that why it is important for you to collect this information. For a quick understanding, assume that I want to check the process efficiency, what kind of test activities are more effective in terms of determining or identifying the defect, then I would be curious on collecting some specific information. For example, the number of defects based on the level, number of defects on the testing activity, and the number of defects based on type of testing, like white box, black box, functional, non-functional, or even if you talk about manual and automation. Now, why would I do that? Now, this is not defect data, but of course, it is a part of defect information, that which level you were doing that time when the defect was observed, and same way the defect was having a count. So when we gather all the data together and create a quick filter, so say for example out of 100 defects you found that 40 defects alone were identified by system testing. Now this concludes to me with respect to my objective that system testing was very much effective at finding defects. But parallelly, I conclude with respect to process improvement that isn't that it is too late for us to find these 40 defects? Only if we have again collected something called as root cause information. And if the root cause information says that it was a coding flaw, then of course we could have found this in unit testing. So what were we doing that? So that is where a test manager is someone who is responsible to define an objective, that what would be our reason or what would be our objective to do the defect management. It is only to track and fix the defects, or is it to improve the process, or is it to do anything else? And that's what exactly we are talking about. So let's quickly have a look on this and get into a deeper dive. Number one, of course, the information on a defect report should suffice for the following purposes. So there are four standard objectives which we have listed right down here. Number one, you can be doing defect management to manage all the defect reports through the defect lifecycle, which is just about tracking the defect and getting them resolved. So we are documenting it. The second objective, assessment of overall project status, especially in terms of product quality and test progress. So this is all about the project status at any point of time, that how we have improved the quality, how many number of defects have been identified, should we do more testing, or do we have defect clusters? So all these things come into this particular objective. The third point here, of course, assessment of status of product increment in again terms of product quality. Now, product increment means if the defects have been a blocker, how much we have done, how much more to go. And product increment simply means the improvement of the quality. By determining X number of defects have been found, we can say that these were the critical defects. And by finding them out, we have improved the quality of the system. So we show the efficiency and effectiveness of testing as an effort. And the fourth objective certainly is related to assessment of overall process capability, which we were just talking a moment back, that how exactly this information can result into overall process improvement. So let's deep dive into this and try understanding what these objectives can be all about and what kind of fields can be used here. So further to elaborate, the information needed for defect management and project status can vary depending on when the defect is detected in the SDLC. In addition, defect reports related to non-functional quality characteristics may need more information, like load condition for performance issues or security issues may have vulnerabilities. However, the core information gathered should be consistent across the SDLC and ideally across all projects in an organization to allow for meaningful comparison of defect data throughout the project and across all the projects. So now we just want to let you know that as you may have different types of defect and different activities being performed, you may have different set of information to be collected. The functional defects may have different set of fields, whereas compared to non-functional, they may have their own set of fields because they are specific to each of them, and their data may also vary with respect to a defect. For example, a performance defect might be interested in number of response time, amount of the response time and the number of users, the type of SLAs it deals with, but functional does not deal with number of users. And same way, if you talk about different objective and perspective, you may have different set of fields to be collected. And that is where it is important for us to understand what is important for us to do. Many data items can be collected in a defect report. The test manager should decide which information is appropriate for effective defect management for a given context due to the fact that each additional attribute increases the time spent on defect reporting and may increase confusion by the person who is entering the defect report. It is obviously advisable to only collect data that is needful for defect management in the given context and will be used for process improvement. Now, very important thing, this is the role of the test manager to decide what would be the template of your defect report, what fields you want them to collect information for, but at the same time, we should not elongate the defect report so much that it consumes extra time, which is not really necessary or not even recommended in the life cycle. So collecting data should be in such a way that it just gives you all that information what you want, but at the same time, do not consume a lot of time. So avoid unnecessary fields. If you think one field can do multiple work, use that. Instead of using 5 fields, if you think it can be replaced by 2 fields, then just do that, because that is what the manager has to decide upon, because they don't want to create overhead for the team so that tomorrow the team feels that I think we are wasting a lot of time writing defect report than actually improving the process. So we have to let them know the objective. Our objective should also be fulfilled at the end of the day, but at the same time, make sure that you're just not increasing the work for them and you are still collecting the required data. Now, to improve that, we are just quickly having a list of those things what we can include. Of course, to manage the defect report is in the most environments, the following are the mandatory information: a defect title with a short summary of the anomaly, the detailed description of the anomaly, preferably including steps to reproduce, severity and priority. Of course, we know that these are the common fields which we look forward to have as a part of the defect management report or defect report information. Plus, on top of it, to add further, of course, additional important data which we can include is unique identification, date and time of the creation, name of the person who discovered it, project and SDLC phase in which it was observed, current status of the defect report, which will keep changing as it travels through the defect lifecycle, current owner, change history, which is the version control. If you make any updates, any changes to the defect information, there should be a version created, and any kind of references, including a screenshot or maybe a video recording, a test case attachment, all that can be a part of the defect report. So put together, these are some of these information which we generally look forward to include, but ISTQB wants to make it clear at this point of time that this is just a typical list of the information. You know your product better, you have a project guideline, you have an organization policy, and you may have your own set of fields on top of it. So it's not that ISTQB says these are the only fields which you should have in your report. These are the typical fields which we generally have, but on top of it, you can have any number of other fields as well. Also, to add here further, just describing the objectives, how they can be fulfilled with respect to certain fields. So depending on the context, further information may also be collected in a defect report, and that we can refer in the standards of IEEE, IEC, or ISO. And the following bullet points group the information according to the intended purpose. So we had 4 objectives. Of course, number 1 is to help detect resolution, the subsystems of component in which the defect lies, the specific test items, its release number in which the anomaly was observed, or the test environment in which the defect was observed. I think again it's making it very, very straightforward that when it comes to resolution, the information what we are really worried about is the test item identification, that is the build, the release number, and the environment in which it was observed. Same way, to assess the overall project status at any point of time, information to monitor the progress include risk, cost, opportunity, and benefit associated with fixing or not fixing the defect, a description of any available workaround or requirement affected by the defect. So at any point of time, if you are giving their status with respect to risk, cost, and time of fixing or not fixing a defect, that showcases the overall project status and how are we progressing on the overall goals. The third objective, of course, to assess the status of product increment in terms of product quality, the type of defect, that is usually corresponding to defect taxonomy, which is taxonomy is basically a document at the organization level which has past known defects listed into a document. So if you're a product-based company, you may have a defect list already identified, and you keep adding known defects into that. So what happens next time when you work on the same product, you take this as a reference to define your effectiveness of the test cases, that these areas will certainly have defects. Okay, or these are the common defects which you always find. So having it documented, that document will be called as defect taxonomy. Okay, so yes, we can talk about defect taxonomy, but as it comes to the product quality and status of product increment, we are talking about defect was where, in which phase defect was introduced, or the quality characteristic or sub-characteristic affected by the defect. And finally, for the process capability, we may have statuses included or information included like the phase of introduction, phase of detection, and phase of removal, and the root cause information to be considered right here. So I think that makes it pretty clear that when we talk about the phase introduced, then where exactly it was detected and where exactly we removed. So it gives me the gap between the whole process. For example, if I identified a defect during system testing, but after a deep RCA, which is root cause analysis, we found that it was a requirement misunderstanding. Now, of course, the defect was introduced in requirement gathering phase, but identified in system testing. So we understand the leakage part here. And then when it was removed, maybe in UAT, then we are very late in fixing the or resolving the issue. So root cause also can be captured here to check the overall process capability, and we can look forward to improvise it from time to time. So that is how exactly the defect information can be collected throughout the life cycle and then can be used for the improvement purpose. So put together, that's all what we had from this particular tutorial. I hope you got a good clarity of that. Should you have anything else, feel free to comment below. I'm always there to address your queries and answer them well. Till then, keep learning, keep exploring, keep understanding the context. Thanks for watching the video, team, and happy learning.